Okay, today we're continuing to talk about the y-intercept and slope, and then writing the equation from that. So in order to write an equation in slope intercept form, the slope and the y-intercept must be known. So hopefully we know that by now. Slope-intercept means that we need those two things to write the equation. So now that we know how to find slope from a table, we're going to learn how to determine the y-intercept from the table and write the equation. The y-intercept, we spoke about this previously, is equal to the value of the y-coordinate when the value of the x-coordinate is 0. So remember, when we talked about this on envisioning it on a graph, it's on the y-axis, right, where that the x hasn't moved left or right. And so it's wherever the line crosses that y-axis. And the way that it's represented in a table is the y-coordinate value when the x-coordinate value is 0. So on a table, we look at the x-coordinates for the value of 0. If present, we locate the matching y-coordinate, and that is the y-intercept. Right, or what we call the b. Okay. So how are we going to do that? So as we know, when we're looking at a table, first thing we do is find the slope. So we find the changes in x and the changes in y. We're going to assume this, we don't know if this is linear or not. So from -4 to -1, I increase by 3. From -1 to 0, I increase by 1. From 0 to 2, I increase by 2. From 2 to 3, I increase by 1. From 7 to 1, I decrease by 6. From 1 to -1, I decrease by 2. From -1 to -5, I decrease by 4. And from -5 to 7, I decrease by 2. So if I compared, -6 over 3 is going to be -2. -2 over 1 we know is -2. We know this is also -2. And -4 divided by 2 is also -2. So I have a slope of -2. Nope, -2, not 32. Then, as we said, we look at our x-coordinates and we find if there is a value of 0. In this case, there's a value of 0. Its matching y-coordinate is -1. So the b is -1. Now I write the equation in y equals mx plus b form. So y equals, my m is -2. That's the coefficient of x. And my b is -1. So I can write that as subtracting 1. And that is how I'm going to write the equation and find the y-intercept from a table, provided that when I look at the table, x has a value of 0. Sometimes it could have a value of 0, but it's just not included in the table. And that's what we're going to look at on slide 2. So second slide. When the y-intercept is not in the table, there are two methods that may be used to determine the y-intercept. So the first one, we're going to call that table expansion. And the second one we're going to call the B method. At least that's what Ms. Scanlon likes to call it. Okay, so we've been given this table, and we can see when we look at the x values, we have -4, -1, 2, and 3. So there's no 0 just listed in the table. Remember, though, these are representing a line, and all those lines, when connected, that means that all those spaces in between are also points on the line. So it doesn't mean that there's not a point that has an x value of 0. It's just not included in the table. Because remember, a table is just a representative of some of the coordinate points that are on the line. It's never in a million years going to have all of the points because there's an infinite number of points that make up a connected line. So what we're going to do is we're going to expand the table, and we need to find out where the value of 0 is. Okay, for this table. We already know, when we looked at the slope, we knew to go from -4 to -1 was adding 3. And we know to go from 7 to 1 is subtracting 6. And we know that our slope is rise over run. But remember, we're not going to leave that as -6 over 3. Okay? We can look at that as just -2, or we can leave it as -2 over 1. That's okay. And basically what that tells me is that every time my x moves 1, my y will move -2. To go from -1 to 0 in the x column, I moved by 1. That means that this has to move by -2. And 1 minus -2 is -1. That means my b is -1. I would again just write the equation, and I don't have to make it a -2 over 1. I can if I want to, but I'm just going to leave it as y equals -2x minus 1. Okay, so that's one way to do it. This was a pretty simple way because I didn't have a fractional slope. It could easily move to 0 because it was one spot away, but it's not always going to be that easy. So a second method, the B method, remember, we're going to find the slope from the table. And we're going to choose one point from the table. Now, I would suggest you choose an easy point, something that's easy to multiply by. Like -1 and 1 would be easy. 2 or -5 would probably be easier than the 7s or whatever else, or if there were fractions in there. And then we're going to take those values and we're going to substitute the values into the equation y equals mx plus b, and we're going to solve for b. Because when you think about it, a coordinate point is made up of an x and a y, and we just found our m. So between having the slope and a coordinate point that's on the line, we have an x, a y, and an m. So we have 3 of these variables, meaning that we'd only have to solve for the b. So what does that look like? I'm going to choose the point -1 and 1. So I'm just going to work off the same table, pretend like I never put in the, I didn't do the table expansion method. What would that look like? Well, according to this, my y is a value of 1 and my x is negative 1. So y is a value of 1, right? And x is negative 1. Remember, I'm following this, y equals mx plus b. So this is y, this is x. We determined that our slope was negative 2, and I need to find the b. So here I just do the math, right? This down below is just for writing the equation. I already know my slope was negative 2. I know my b is based on this equation. So negative 2 times negative 1 is going to give me positive 2. So now I have 1 equals 2 plus b. And to isolate b, what would I have to do? I would have to subtract that 2, or actually add a 2 to both, or no, subtract the 2 from both sides because this is now positive. So 1 minus 2 would be negative 1. I still have y equals negative 2x minus 1. And I'm just going to reiterate what we did. I'm going to put a little extra box over here. So when we were doing the math, we determined that 1 equals 2 plus b. So to solve the equation, we have to subtract 2 from both sides of the equal sign. And that left us with negative 1 equals b. So that was us just solving, a one-step equation after we did the multiplication. So that was what allowed us to find b as well. So oftentimes when the y-intercept is what we call hidden, you'd be better off using that method, that second method that we just talked about. Quantum moves really slow today. Anyway, you have two GPs. You have one where the intercepts are not going to be hidden, and you need to find the m and the b and write the equation. And then we have one when the intercept is hidden, and you're going to have to choose your method. You can either do table expansion or you can do the B method. You don't have to do them for all of them. Maybe for the first one, you think table expansion is easy, so you do it there. But for the second one, it's not as easy, and you wind up doing the B method. So it will be up to you to make that choice. And that is how to take a table and find the y-intercept and write your equation along with your slope.